In this video, we are going to look at some word problems exploring weighted averages. Let's hop right in and try some examples together. A candy shop owner is mixing up a batch of his candy medley. Overall, the medley costs $2.95 per pound, and it is made of jelly beans costing $3.30 per pound and gumdrops costing $1.55 per pound. How many pounds of each should the owner use in a 30-pound batch of the medley? Let's start by making a table. The candy shop owner has two different kinds of candies, jelly beans and gumdrops, so those will be our first two rows. The owner's goal is to have a 30-pound medley with a mixture of the candy, costing $2.95 per pound. This will be our third row. Our columns are going to be the cost per pound of each candy, the number of pounds of candy, and the total cost. Let's begin by writing our costs in the first column. $3.30 for the jelly beans, $1.55 for the gumdrops, and $2.95 for the medley. We know that our goal is to have 30 pounds of the medley, so we can write that here. We are solving for the amount of both jelly beans and the gumdrops. Instead of choosing two different variables, let's use one variable, x, to represent the amount of jelly beans. If we want 30 total pounds, and we know that x is the amount of jelly beans, we know that we should use 30 minus x pounds of gumdrops. Nice! Now we can multiply across to fill out the third column. So 3.3 times x, 1.55 times 30 minus x, and 2.95 times 30. Great! Now we can use the information in the last column of our table to write an equation. We know that the total cost of the jelly beans plus the total cost of the gumdrops should give us the total cost of the candy medley. So we have 3.3 times x plus 1.55 times 30 minus x equals 2.95 times 30. Now we can solve. On the left side of the equation, we'll distribute. So we have 3.3x plus 46.5 minus 1.55x. And on the right-hand side, 2.95 times 30 is 88.5. Now we can combine like terms. That gives us 1.75x plus 46.5 equals 88.5. Subtracting 46.5 from both sides gives us 1.75x equals 42. Finally, we'll divide both sides by 1.75 to get x equals 24. That means that the candy shop owner should use 24 pounds of jelly beans. We still need to find the amount of gumdrops. We can use the equation 30 minus x. Now we know x, so we can plug in 24. 30 minus 24 equals 6, so the owner should use 6 pounds of gumdrops. In summary, the owner should use 24 pounds of jelly beans and 6 pounds of gumdrops in the medley. Nice! Let's do another one. Amanda works for a company that manufactures liquid dyes for clothing. She currently wants to mix up some 38% concentrated pink dye. She has 54 liters of 26% concentrated pink dye and plenty of 46% concentrated pink dye. How many liters of the 46% concentrated pink dye will Amanda need to add to the 26% concentrated pink dye to make a batch with a concentration of 38%? Let's make a table to help us organize some of our information. We'll start with what's given. Amanda has two different dyes, one with a 26% concentration and one with a 46% concentration. So those will be our first two rows. Her goal is to have a dye with a 38% concentration, so that will be our third row. We are given information about dye concentration, volume of dye in liters, and the amount of concentrated dye in liters, so those are going to be our column headers. Let's write the concentration as decimals in our first column, so 0.26, 0.46, and 0.38. In our second column, we know that we have 54 liters of 26% concentrated dye, so we'll write that here. Let's use the variable x to represent the quantity of the 46% concentrated dye, since that's what we need to find. There are 54 liters of 26% concentrated dye and x liters of 46% concentrated dye, so we have a total of 54 plus x liters of the 38% concentrated dye. We can write that here. Now we can multiply across to fill out the third column to find out how much concentrated dye there is. In the first row, we have 54 liters, and it is 26% dye, so the amount of concentrated dye is 0.26 times 54. In the second row, we have 0.46 times x, and in the last row, we have 0.38 times 54 plus x. Great! Now we can use the information in the third column of our table to write an equation. We know the amount of dye from the 26% concentrated part plus the amount of dye from the 46% concentrated part is equal to the amount of dye in the resulting 38% concentration. So the sum of our first two rows is equal to the last row. That gives us the equation 0.26 times 54 plus 0.46 times x equals 0.38 times 54 plus x. Now we can solve. On the left side of the equation, 0.26 times 54 is 14.04. On the right side, we can distribute, so we have 20.52 plus 0.38x. Subtracting 0.38x from both sides gives us 14.04 plus 0.08x equals 20.52. Now we can subtract 14.04 from both sides, so we have 0.08x equals 6.48. Finally, we can divide both sides by 0.08, so x equals 81. That means that Amanda should add 81 liters of the 46% concentrated pink dye. Great, I think you're ready to try some problems on your own.